Hey, hi everyone. This is Sai from Let's Upgrade. So let's talk about how to get your certificate. It's very simple. You will see two links in the description. Number one is the place where you have to go and mark your attendance. Marking your attendance tells us, like, okay, you are a legit student who have attended this particular session. Link number two is your assignment. This is where your 90% of the priority is. You have to go and submit the assignment that is given to you in this particular session. Once you're done submitting that assignment, we will be evaluating that. We will send you an email. If you get the passing criteria, then only we will give you the certificate on a particular date that is mentioned again in the description. Please check these three things, and this is the way how you will get a certificate from Let's Upgrade. Number one, mark your attendance. Number two, just go ahead and upload your assignment. Check for the email that you have received it, yes or no. What is the feedback that you have received from your trainer? Number three, check on which date the certificates will be released. Thank you. Bye. All the best. Happy learning.
All right. Welcome, good evening, good afternoon to all of you watching this session with us on YouTube Live today. This is your host, Gaurav Deep. I am an AI enthusiast. I work in the field of machine learning and AI from a pre-transformer era. Okay, so we have I have personally worked a lot in the field of natural language processing, starting from your recurrent neural networks to LSTMs to transformers to this generative AI, right? So I'm really excited to bring up this session to you all, especially today because the kind of learning, the kind of session that we are doing today is not limited to just IT professionals. It's not limited to maybe a tech person. This kind of session can be useful to even someone who is just in school, college, learning. Maybe you are in your PhD, maybe you are just starting out with your seventh, eighth, ninth standard of education. In any walk of life, if you are planning to learn something, if you are planning to question something, then this type of session is definitely for you. Now, the kind of agenda that we are setting today, right? So, of course, the title of the live session is supposed to be the Socratic way of tutor. All right, like that's what we're going to build. We're going to build a Socrates kind inspired of maybe a bot which can help us learn the art of asking, right? So I think that's the more correct way of what we should call this live session. It is the art of asking, turning maybe your large language model like a Gemini to Socrates mentor kind of a thing, right? Well, with that being said, the part one of how I would like to start off with you all would be to take you back in the history. Okay. Now, when I say take you back in the history, I want you to go back with me, open up your mind of imagination to around maybe thousands of years back from now, maybe 2500, 2400 years back from now. Okay. Now, just imagine that. Even before we write anything, even before we do any prompt, let's go there. Imagine like we are walking through a dusty ancient streets, Athens, okay, somewhere around that, and we are just casually strolling. We are having some thoughts in our mind that maybe in that those era you will obviously not think about generative AI or prompting, but maybe your questions would be, what is the meaning of justice? Imagine like how today's developer would say, what is the best algorithm, what is the best sorting algorithm to choose from, right? And of course, you happen to run across a man named Socrates, okay? He's barefoot, he's wearing his traditional old robes, he's kind of annoying the way he appears, locals are annoyed with him, but you happen to ask him a question, okay? And the question is, you ask that, hey Socrates, I was just wondering that what is the true meaning of justice, okay? So this person that you have just met, he is a kind of a fly who is needed to sting a horse to keep it moving. Now, what do I mean by that? It's like he is kind of a person who really wants to punish your brain. He wants you to use your brain to think, to derive, and to conclude. And find points of failure, and then improvise on top of it. Something how today's agentic models are being trained, right? Self-corrective generative models, thinking layers, okay, proactive actions to be taken. If agent is failing somewhere, reflect on it, why it is failing, and then try to improvise on top of it. Now, something like reinforcement learning, really, right? So, now let's come to the modern world. Let's fast forward back to our era. Right now, Socrates is gone, but his ideology is still with us. So now let's imagine we are sitting in front of our computer. It's midnight 2 a.m., no one to call, not even our professors, not our seniors, not our mentors. We are stuck with a problem statement. Say, for an example, if you're a developer, you're developing something, your code doesn't work, it's breaking. You have a quick hack. Just copy everything, copy your trace, copy your code file, throw it on ChatGPT, throw it on Gemini, ask these models that please fix my code for me. And what happens is that these models, they generate the updated answer for you. You blindly copy that, blindly paste it in your file, try to run that script again, Python main.py, you're running it, and somehow maybe it works. Now, God knows what that code was. Was it even the most optimal way to write it? In fact, forget that. Let's come to the most important question. Did you learn anything? No. Did you solve a problem? Yes. Will you be able to solve this problem again? Probably not. Right? Now, I don't need you to self reflect. I think the question or the premise that I've set is pretty clear that why will you not be able to solve the problem again, probably, right? So, today we are going to take that part. Today we are going to change how you use these models. We will stop thinking about these models to be generative. We will stop thinking about these models to be replacement of Google search, replacement of generation, but we will learn the art of how we can use these models in the Socratic tutor manner. All right, then, people, let's code the future. So I hope my screen is visible to all of you. Let us quickly spin up the Gemini or OpenAI, whatever you want. Let me bring up a browser on the screen. Let us go to Gemini.com. But before we go there, I'd like to show you the correct way to use this would be through studios. Okay, so if you are planning to use OpenAI, let us go to openai.com. Okay, I'll explain you how this part works. So this is the by default the de facto location of OpenAI, but we don't want to be here. We want to be somewhere in the chat completions. Sorry, the studio. Let me first log in over here. Okay. So whenever you have to log in, make sure that you use the correct credentials. For now, I think I'll just go back. Open AI Playground. So OpenAI likes to call their studio as Playground, and we go on platform.openai.com. This is where we are, platform.openai.com, and you can say chat, edit, model. They have selected something for us. Now, before you reach here, you will have to make sure that you have logged in with your account. And once you log in, what you can do is uh, I'll come to it. I'll come to this part later. Okay. But first of all, this is one way. But remember, all the students and all the learners who are here, if you prefer to use OpenAI, I believe you will be aware of the billing involved. OpenAI is not by default free for all the models. Some models they can still be available to play around with. Okay, not sure about the free versions over here, but definitely you can try something from these lots. Okay, now so for an example, if I change my let me go back to my personal level. Okay, this is my free account. So on free account, it will first say payment method needed. You need to set up a billing account. We click on this part. We need to add some balance, add payment details. Okay, continue, add payment, and then go back to the general usage. Okay, so go back to the chat part, and in order to use that, you will have to make sure the account is paid. So for me, I think I have some different organizations in which I work, and I can just show you how the usage looks like. And then we can go back to my favorite, which is AI Studio. AI Studio is always free and always abundantly available to anyone, any student. Okay, now especially Gemini 3 Pro has come up, and this is my personal favorite model these days. Okay, it's really capable. In fact, I was always in love with Gemini even when we were in the 2.5 Pro era. Okay, but with that being said, voila, there's a new model. I'm really happy about it, but you see that this model will come up with its own limitations. Jan 2025 knowledge cutoff, whereas if you go to 2.0, it is also Jan 2025 cutoff. It is just a little bit improved version that is available, but in no means that 2.5 Flash or 2.5 Pro will be less of a substitute. They can be easily chosen as your default choice. Okay, you can go in with Flash models, no problem. So, for an example, this is our hybrid reasoning model. This is fair enough for us. We can take it. Now, this is the AI Studio. Okay, AI Studio belongs to Google, Playground belongs to OpenAI, but these are not the only two default platforms where you can work in. Okay, you can also work in with your open source models. So, if I have to talk about for some more interesting ways to use, one would be Olama. So Olama is really a great software to begin with. So to chat and build with Olama models, you can download the setup from here. Olama works totally local. When I say local, it means that this particular software will use your laptop's hardware to generate response, laptop's storage to store the model locally. So even if the internet is not working, your model will work locally. Okay, that's the idea over here. So once you download the Olama, you can completely run through the installation process. You can. That's a very straightforward process. No need to show it. Just click on download. You can choose which platform you want to work on. Just download the executable. It is very simple. Double click, next, 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 and the file is installed. So for example, if I like to show you how Olama looks like when it is installed. So here we are. The list of models which you see over here, many of them will have downloaded in front of it, which means that this model is not yet downloaded to my local. I need to install it and store this on my local. Okay, but again, for some symbols with cloud, it means that these will work with uh, not on-prem solutions but on cloud solutions. So this will be still consuming your internet, and on top of it, some models which are open source and you might have, like I have installed, is available here. If you don't have some model, you want it, you can simply click on download. The model will begin. Now, for people who are wondering how much storage will be utilized to install such models, I'll just recommend. Now, I have one doubt about my screen recording, so I'll be pausing my video. Okay, I'll be just checking if my recording is happening correctly. Okay, since the recording is happening on track, my screen is visible. Let's go back. So now I want to show you how can you figure out which model will work and suffice based on the storage capacity, right? So to begin with, you can also think about something as huge as maybe hundreds of billions of parameter model. But if we skip that part, see, for example, DeepSeek could have something as huge as 671 billion, okay, which would not just require a half a terabyte of storage on your you can say computer, which is like 500 GB at least of the space you need to run it. But at the same time, I'll tell you that why it is not quite possible for a normal human to run such models, right? So there's a website known as apxml.com. Apxml.com is my favorite website when it comes to figuring out which machine learning model can I run locally. So I mean, you all might be, if at all, if I give you, can I run GTA 6? So for all the you can say gaming fans, You might be aware that there are some websites like Can You Run It or PC Benchmark, which always tell us for the given use case, can I run it on my local, right? So similarly for the generative models, we have something like apxml.com tools VRAM calculator. This is really good. It can really help me understand if I can run it locally. Okay. So firstly, I need to come here and give my hardware configuration, that what kind of machine do I have. Okay, so currently if you say that I have a very small GB GPU, maybe I'll just come back over here and put in something as low as, let me check what is the minimum they support. I think yeah, they also have MacBook Pros. Okay, and apart from MacBook Pros, they also have AMD series graphic cards, and mostly I think people will have something like NVIDIA based graphic cards. So we'll pick a very small one, 8 GB graphic card. Okay. Now, of course, when I say you have to run large language models locally, you can offload it. You can enable offloading to CPU and RAM. Okay, if at all you are planning to use it locally. Okay. Now, number two offload, I think you will completely offload and offload KV cache to CPU RAM also. Okay. Now, this is something that can be checked over here. But if you have by default graphic card based laptop, you will see your performance coming in right over here. Okay. Let me zoom out a little bit. Okay, or in fact keep it zoomed in. Okay, now I'll choose a correct model. For example, on Olama, if I want to see that can I run gamma with me. Okay, so I'll recommend at least to go with something like 4 billions or bigger, actually, because the kind of problem statement we are solving today, it will require some good amount of reasoning model. Okay, so if you can somehow support something like 12 billion locally, let us search for gamma 12 billion, even 8 billion, 7 billion will work. Okay, that's not the problem. Even 4 billion can work. Let's stick to 4 billion in this case. Inference would be, of course, in do not change this value. KV cache do not change this value. Batch size is fine. Sequence is okay. Even if you tweak it a little bit, it won't bite much of your VRAM. Only one single concurrent user. And in the bottom, you will be able to realize that, oops, I cannot run this model. Now we go back and we change this you can say inference to Q4KM. Okay, now what does Q4KM mean? That it is a quantized version of the model. If you are by default downloading it from Olama, they serve quantized versions only. Okay, so if we click on it, you will realize that if you click on this model, you will realize that quantization is Q4KM. For people who are non-tech, for people who are here just to understand the prompt, be patient. This type of tutorial that I'm giving is more from tech perspective people. That is, if you want to run locally models, I'm just giving you one solution how you can do it. Olama is the way, and you can pick this model. So Q4KM, as soon as you hit on top of it, you will realize that now even something like a 4 GB GPU can inference this model. Okay, 3.8 GB of loading will be needed on a CUDA compatible GPU, or any simple 4 6 GB. Even if you have 6 GB GPU nowadays, laptops for something like, I have my own laptop which is 4060 8 GB RAM VRAM. Okay, I'm talking about the graphic cards memory. That is sufficient to run such a model locally, and it will give you a very good throughput. 87 tokens per second is a very good throughput. Okay, now not wasting much time over there, this is the this is just, I want to give you an additional information. If you want to keep it, if you want to run something like this, there are many more ways, there are many more platforms through which you can run generative models, but my pick for today would be the OpenAI and Gemini Studios. Okay. Now, when we have to run any model, the very first thing you will do is choose your model. I think I have chosen 2.5 Flash. Okay, because I want the model to be little quick and fast to generate a response. If you choose more about the Pro series will take a little bit of more time to think and then come back to us. Okay, that's the catch here. In the same way, if you go to OpenAI, you can in fact you can write a good name about your prompt. You can choose the model, maybe for 4.1. Okay, that's fine. If you want, you can go with 5 mini. Okay, that should also work, whatever works for you. Now this is where I wanted to write this system message. Okay, so everyone, we will do this hands on. We all, even if you're on Gemini, we will write system instructions right from here. Okay, so in the right side, if this window is closed for you, on the top right, you will see this settings button. Click on it and open system instructions. Okay, let us write the prompt title. And what better than the say Socratic, okay, we can say master. Okay, that's the idea. Now I want you all to please be with me. We will do live test. We will write this. Okay, now we will write our own prompt. Okay, so we will say you are an expert professor. Okay, the best in depth master of your field. Okay, now in the subject of, now this is where I will leave your option. Okay, this is where you can fill in whatever is your choice. So for an example, if I want to talk about physics, I'll say physics and astrophysics. Okay, so astrophysics, so for people who are wondering what I'm typing here, astrophysics, if we Google this term, so astrophysics is a branch of space science that applies the law of physics and chemistry to understand the universe and the celestial objects within it. Okay, so this is what astrophysics is, and this is something that I want to build as a prompt on top of it. So you can always modify it to be a chatbot. You can always, of course, a chatbot. You can modify it to be a domain expert in computer science, a domain expert in your field, or wherever you want to use this bot. Okay, that's the prime idea. Now, this is the premise. We have set the premise. Okay, now we want to add few things into this prompt. Okay, so. Instead of directly answering me the questions, okay, I want you to use the Socratic method. Okay, now the LLM would be pretty aware of what this method is. This term might be really alien to us or someone who is hearing it for the very first time, but if we search Socratic Socratic method, and if we even if we go to Wikipedia, let's go to Wikipedia, and even the AI has generated some answer for us. We will realize the Socratic method redirects here. Okay, the Socratic method, also known as Socratic debate, the Socratic dialect. Some of it is a form of argument dialogue in which an individual probes a conversation partner on a topic which with questions and clarifications until the partner is pressed to come to a conclusion on their own, and else their reasoning breaks down and they are forced to admit ignorance. Okay, that's the idea. And if you go to the development, you will realize that all the story that I told you, you are going in Athens and ancient time in Romanized ancient Greek, you are moving in, you will realize that this person used to use this technique to teach people, to make people more active by their brain, and to help people learn the actual correct way. Okay, so that's one way of learning, and it is a dialogue between teacher students. Okay, and it is on the premise of that can we learn something. Okay, so five stages of the Socratic dialogue are: wonder, receive what the other person has to say. Okay, listen to their view or premise. So this is very much similar to when we set up, you can say, a hypothesis. When we even talk about something, let's first understand what the student is bringing to us, then reflect. The second stage is reflect, sum up the person's viewpoint and clarify your understanding of what you heard. Okay, the reflection is also a part where you confirm and you let the user agree that have I correctly understood your part. Okay, so for example, if I am trying to explain you that how machine learning works is by maybe I'm telling you that we have some set of algorithms on which we train the model to learn weight and biases, and once the model converges, we have that. Okay, so maybe the teacher will understand, the tutor will listen to what I have to say, and they will reflect coming back to me. So okay, this is what you said. You said that weights and bias, they are a part of this, and when you say it converges, you mean something like this, and if it is what I meant, I'll say yes. So then you refine and cross examine on top of it. So ask the person to provide evidence that supports their view. When we say evidence, it could also be to add some more clarity, it could also be to add some more that's where you can discover thoughts, right? Some assumptions or underlying facts. It could be just underlying facts, underlying assumptions. It could be beliefs. It could be proofs. But then you can challenge these assumptions to test their validity. Okay. Then you restate. Note the new assumptions resulting from the inquiry, and then you repeat. You repeat this loop over and over again. Okay, so that's the stages of Socratic learning, and I hope that rectifies your further understanding about this topic. Now, okay, let's open this image. I think this is really interesting, the sarcastic and the Socratic method. Okay, what can we say about this phenomenon? Well, what are your assumptions? So that's the Socratic way, and what do you base for the reasoning? Okay, so that's again one example in which how the Socratic teaching is supposed to work. Let us check where is that image. Yes, right over here. Right click open, and if we zoom in, you will realize the modern Socratic method. What is a square, my friend? It is I'm not sure. A square is a shape with four sides. Okay, so examination, I see. And are there any other shapes with four sides? What about a door? So response is yes, a rectangle has four doors. New hypothesis. Then I suppose a square is a shape with four sides of equal length. Okay, that's the way we are helping someone get more with the reasoning to why a square is what we call a square to be. Okay, why a rectangle is not a square, and why door is not of a square shape usually. Then the reasoning solidifies, the concept solidifies, the meaning solidifies in your brain, and you actually learn through this pattern. Okay, it's a very interesting pattern, and you can always come here, read more about the Socratic method. Okay, Socratic questions, clarifications, probing assumptions. If you are more interested in the philosophy also of how this was supposed to work, I think, yeah, I encourage you people to go ahead and learn this blog and see what Google has to offer. Okay, read through few blogs, you will realize and get more absorption about this concept. But I think we are pretty, you can say, pretty much okay with whatever we know at this point. Now we have started off writing a system prompt. I will just also help you understand what a system prompt is supposed to be. So uh, even before I do a Socratic method, let me explain you what system prompt is. Okay, that's something I should have done earlier, but never late than never. Okay, it's completely fine to even to cover it right now. So system instructions. I am creating maybe. So we all need an iconic characters. Okay, so I'll search most iconic Bollywood characters, something that should be common with all of you. I think yes, Gabbar or Mugembo would be best. So even if I cover something like Mogambo is more common. Okay, Mogambo. I think you have seen these characters. Okay, so you are an interesting person, Mogambo, from the Bollywood movie. Okay, you should talk and mimic this. character while someone chats with you. Okay, so let's go back and let's start one more AI session. Okay, and over here I'll keep the model same. I'll keep, so this is a system instructions I'm embedding in 2.5 flash. 2.5 flash, I'm using no system prompts. Let me ask a question about uh, what is Python programming language. Okay, let me ask this question. I'll okay, escape, run this. Now, by default, the model should okay answer me a very decent answer. Python is high level general purpose and so and so and so. Readability, dynamic, garbage collected and so on. Now let us go back. We will not change temperature, not change the model. We'll keep everything same. We will ask this question, right click copy and right click paste. Okay, to keep everything same, I'll not change any token characters, keep it exactly same. You will realize that Python, my dear friend, you ask about Python, that is a versatile as Mogambo himself, Mogambo Khush Hua. So what is Mogambo? It is a high so what is Python? It's a high level general purpose language created by this, and now let me tell you why Python is so and so. Okay, I think that's a little bit of personification that's available here, but you can make your model really dance to the kind of thing you really want from it, right? So that's the idea about system instructions and why we are writing it. Okay, we want the system to behave in the way we guide it to. So you are an expert professor, the best in depth master of your field in the subject of physics and astrophysics. Instead of directly answering me the questions, I want you to use the Socratic method. Okay, so that's the answer. I want to learn a new concept. Okay, that's fine, but I do not want you to answer in the first attempt itself. Okay, wait for the explanation and teaching. Okay, instead, when I ask you a question, the very first thing you should do is encourage me, okay, to maybe first, number one, ask me a question, okay, at a time to gauge my current understanding. Remember, I told you that there's a process in which we make it. So I also showed you one image in which 5 steps were mentioned. Okay, so based on my answer, you can say, guide me towards the correct concept. Okay, maybe by asking follow up questions. Okay, that's one way, or maybe or challenging my assumptions or beliefs, okay, something like that. Then if I am stuck, uh, provide me a small hint to begin with. Okay, the full solution can still wait. Have patience. Okay, let's start it in a better way. Provide us, begin with, observe if I am able to catch up. Then my goal is to increase my learning by strong foundation. Only in last resort, if I deliberately ask you to give me the information, full learning and information, only then choose it the last resort to help me learn. Okay, so that's the idea. Okay, and so are you ready? Let's start. Now, the best part is you can always save this prompt whenever you want it. Okay, so this prompt is now saved in my system instructions. So even if I close this browser and I come back to the AI Studio or the OpenAI, in that case, okay, I can always you can save your current configurations to create your first prompt. If I save it the way I am saving it on the Google Studio, I can always come back and from the drop down select the prompt I want. For example, for HR bot, this is my bot to teach the HR people. For example, this is my bot to work with the senior developers working on a particular project. For example, prompt master is something which helps me write better prompts, and similarly I have the Socratic master which will now help me learn about physics. So I can always in bracket write physics to if I have to duplicate multiple of such you can say prompts. Okay, so that's the idea right over here. Now, when we are here, so next thing that you all can pay attention to is the temperature. So temperature is something that makes the generative model creative or versatile or truly generative, in a sense that if I increase temperature, I am increasing randomness, I am increasing you can say randomness basically. That's the way I'll put it. So of course, if randomness is increasing, I am hampering my chance of getting more correct values, because randomness can increase creativity, but at the same time, let the model get more confused and hallucinate. In my case, I want the model to be a little creative, but lesser side. So 0.35 is generative, like generous for my thoughts, but you can always play around. Do I need thinking mode? If I disable it, the model will generate really quick answers. I can start off with you can say I can start off with some thinking mode. Okay, I can set thinking budget to be very less. Okay, so that model should not invest a lot of time in thinking. Okay, what is thinking mode? If you are asking me that, thinking mode is allowing the model to reflect on what we are asking. So, for an example, if I ask that write a code in Python 3.10 about maybe write a code for calculator. Okay, design a calculator. If I switch off the thinking mode, the large language model or the generative model will directly pick up the most important tokens, maybe pick up Python, maybe write a calculator code, it will give me a code. Okay. Since it is an easy request, chances are it will deliver it the correct way. But if I keep the thinking mode on, the model will first self reflect what is asked to write a code. It will ask about what? About a project on writing a calculator application. Where, which language? The model will self-reflect, ask itself some questions. The model will say Python. Is there any details? It will say yes. Python specific version 3.10. Okay, then of course it won't make much difference, but model will have more better grasp to you what you're asking. It will take some time. It will self-reflect and then generate the answer for you. Okay, that's what thinking mode does. So thinking mode is really useful when you are asking something really complex. In our case, of course, we can benefit from thinking mode. In fact, if you have patience, you can increase this much further. Certain tools which not will not be needed at this point would be structured code function URL. I'll not explain you this. They are not even needed here. You can keep it. You don't need to change anything at all. In fact, I will say this is not at all needed in your case. You can leave the temperature to be wherever you are, or keep it on zero point 0.5. That's the only thing you can change. Don't even need to bother about this point. Just begin with it. Okay, let's just start. So let me ask this model a question now. I was wondering why moon never collides with Earth if my assumption that Earth moves around Sun is correct. Does this mean that, of course the question is dumb and I want it to be like that. I'm trying to mimic someone smaller in my age asking this question. Does this mean that uh, okay, how do I even design it? Does this mean that okay, let's leave it to that point. Okay, let's try to ask this question. Now I was wondering, okay, now why moons? So you will see that's an excellent observation to start with. Okay, your assumption that Earth moves around the sun is indeed correct. So that's a positive reinforcement that the Socratic master is giving me. Now let's consider the moon. How would you describe the moon's motion in relation to Earth? What do you think is happening there? Now, do you see how crystal clear the model is? The model first wants to understand from me what I understand about moon. Okay, now why this method is beneficial, I'll tell you. Because when I was a student, when I was learning physics, mathematics, chemistry, be it anything from my teachers in my school, I had some pre-beliefs. I had my own assumptions. I had my biases. Okay, when we started with our topic, but since teacher was directly teaching us the correct path, or the professor was directly giving us a solution, whatever inflict I had in my mind, my bias, my thoughts, my conflict in my reasoning would need to be suppressed. Okay, I would have to suppress my brain in a way that, Gaurav, for now forget it, just mug this up, or just try to take up this as a concept. Maybe you are dumb enough, maybe your reasoning is going off the track, we don't have time, the exams are coming up, okay, or maybe I have to deliver something and I do not have time to self reflect. I was killing my own innovation, and teacher would never understand why I am facing this gap, because no one would actually understand first my thinking. No one would actually first point out that are there any assumptions I have, because if they have, only then they can break that ice, only then they can clear that path for me to absorb that why moon never collides in earth. Okay, I will say I think, okay, I'll write something dumb. Okay, I think moon is static uh, because whenever I only see one side of the moon. It never moves. I think this is dumb, but why not? Let's try this. That's a very keen observation about always seeing the same side of the moon. Many people notice that. Now let's think about that a bit more. If the moon was truly static, okay, just hanging motionless in the space, what do you think would happen to it due to Earth's gravity? Would it stay in the same place indefinitely, or would something occur? Now, to be honest, I will assume that this child has uh, just a second has understanding about the Earth's gravity. So I will say, if Moon was static, it would collide in Earth because of the gravity. Okay, okay, but it does not. Let us answer this. Sorry, I got a call in between. Okay, so precisely you have hit upon a very important point. If the moon was truly static, Earth gravity would indeed pull it, leading to a collision. Since it doesn't collide, and we have established that it's not static, what does that tell you about moon's motion? What must it be doing to avoid falling into Earth despite gravity's pull? That's really pressing my nerves, I would say. Okay, this is a gap in my knowledge. I am not sure what would moon do. Okay, so no worries at all. This is exactly how we learn and build a deeper understanding. Let's think about it with a different analogy. Imagine you are holding a ball and it just you if you just drop it, what happens? If you throw it horizontally with some speed, what path does it take? How does that horizontal motion affect how long it takes to hit the ground, or even if it hits the ground in a very specific scenario? Okay, so okay, it's now this is the best part. This is the best part about this type of learning, that it will give us some analogy behaviors. Okay, so imagine you're holding a ball, okay, and if you just drop it, what happens? And if you throw it horizontally, okay, with some speed, what path does it take? Okay, so if I just drop it, it vertically falls down. If I throw throw it horizontally, it takes projectile motion. Now, of course, as a student, I will assume that people might have doubts in projectile motion also. So maybe you might have to go from some layers to even understand projectile motion. Excellent, you have got the core idea of projectile motion. Now, because since my master knows that at least projectile motion is clear to me, now let's extend your thought on to a very extreme scenario. Imagine you could throw that ball so incredibly fast that as it falls due to gravity, the Earth's surface curves away beneath in the same rate. What do you think would happen? Would it still hit the ground, or would it just keep falling around the earth? See, it's really pressing my nerves at even at this point to be in two different zones. Okay, even to pay attention over here, even to record this lecture. But yes, I would simply say that yes, it won't hit ground. Okay, something like that. So let's see what kind of answer it has. Exactly. You have just described the fundamental principle behind orbit. Now, knowing this and knowing that the moon doesn't collide with the Earth despite Earth's gravity, what can you infer about the moon's motion around the planet? How does it relate to that ball you imagine? I think the moon is constantly falling or something like that. It is following a projectile motion, maybe. Okay, so that's where you can grow deep. You can grow deep, you can learn your concept to a very great depth. Yes, absolutely on the right track. The moon is indeed constantly falling towards the earth, much like a projectile motion. But here is a crucial part. If it is constantly falling, why doesn't it hit the earth? What must be accompanying that falling motion to keep it from colliding? Think back to our discussion about throwing the ball in the very first place. It is incredibly infinite loop of never ending to fall. Maybe it's trying to take me to the point of orbit. Okay, that's a fantastic way to put it, an incredibly long infinite loop, never ending fall. You have captured the essence very beautifully. Now let's connect the never ending fall back to our analogy of throwing the ball so fast that it wouldn't hit the ground because the earth's curved away. What was the key ingredient beside gravity that allowed the ball to keep missing? Oh, okay, it's the escape velocity concept that the moon now is trapped like a satellite. Okay, now let's see where it goes to. Yes, very close. And the idea of the moon being trapped like a satellite is absolutely spot on. The moon is Earth's natural satellite. Now, let's just clarify one more term that you mentioned, escape velocity. What does escape velocity mean? Typically, allow an object to do. Okay, if something reaches escape velocity, what is the ultimate fate in relation to a gravitational body near it? Okay, so you see, it is really going to press us a lot to develop that kind of understanding. So, whereas I will take a stop over here, it's a quite a long loop when you actually learn a concept. But I really enjoyed this session myself. Okay, I being you can say enthusiast of physics. Also, I love to learn, read about space. I think that you all might have also enjoyed the session. And if you have any queries, any doubts, please reach out to us. And I will encourage you all to go ahead, experiment this kind of learning in your fields. Maybe you can ask it to help you write a debug a code session. Okay, maybe if your script is not working, you can ask that. Maybe you can just take up a Python script, maybe take up any programming language script, whatever language you want, put it and say, see, I want to learn machine learning, see, I want to learn PyTorch, how does it work, I want to learn how to train models, or maybe I just want to learn to write a code. Okay, teach me. then I think that's the way in which the model helps you learn in a way that you self reflect, self learn, grow with more confidence. So I hope the session was really interesting, people, and you are taking away some instructing prompts, interesting prompts with you. Save these prompts at your level. Okay, you have these prompts forever in this recorded video. Use it, have fun, and in the comments, please, I recommend, please, in the comments, do reach out to us saying what did you try, what concepts did you try, what was your professor. Share us some interesting ways in which you asked a question, what the bot answered, so the community can learn and grow and inspire. Okay, so once again, thanks to all of you. Big shout out to all of you being present live over here and watching this session. I will take your farewell. Tata, bye bye, good night, sayonara.